So now we want to look back at our graph and take a close look at what we see happening as time progresses with this equation. In other words, what happens as x gets larger and larger and larger? If you're interested in heading towards calculus, which I encourage all of you to go check out, what we mean here is what happens as x goes towards infinity, gets really big, what's happening to these y values. In particular, we're looking at the steepness of the graph. So let's jump to Desmos. And I'm going to zoom in here just a little bit. And I think you can see that in these early points, the steepness of this graph it's not that great, honestly. Well, it's not that changing. Okay, so we've got looks almost linear right here. But as we zoom out and go further and further towards that infinity, you see that this line starts to straighten out and almost becomes vertical. If we zoom out far enough, it looks like it's just going vertical. Now, if you think what's happening conceptually here, we're looking at time here on the x-axis. So 1,000 years, is anyone going to live for 1,000 years? Not unless you're Fry from Futurama. Is that really going to happen? But you can see that given enough time, the value of your account explodes. Let me illustrate something. I'm going to type in x equals 200. So this corresponds to when 200 years after you deposited that $10,000 in your account. Look at the massive amount of money you have. 7.529316 times 10 to the ninth. If we want to see that on the graph, my goodness, that's going to be a struggle. There we go. There's our value. Again, you can note that in these early stages, there's almost no growth in the y value based on the scale, and then it just explodes. That's what we're to note here. That's the power of the exponential function. So we've got a couple questions here. How much interest will you earn from 0 to 5 years into the investment? Well, what this question is really asking is an old question you asked before. What's the difference between the amount of money in the account for 5 years and the amount of money in the account at 0 years? In other words, new minus old. So we're going to have to grab our values from the table. Where is my table? Here it is. So we're going to look at that 5-year value. That is 14,025.52 minus the 0-year value, meaning the initial investment. And notice the 10,000 just goes away, and we're left with $4,025.52. So what does that mean? Well, that means we earn this much interest over the 5-year period. So interest earned in the first 5 years. And then our author says, all right, let's figure it out for 35 and 40. Well, our table doesn't give us those values. And also, he told us to estimate this thing. So here's year 0. This is 1, 2, 3, 4, 5. Here's year 5. So that $4,000 in our graph looks like this amount of change, that tiny, tiny amount of change. And then we're going to year 35, which we're going to call this, and year 40, which is clearly this. Now you can clearly see, hopefully, the amount of change is much larger. If I were to compare these two, I'd say this is maybe 4 times larger than that one, just looking at that vertical length, which is representing the difference between this new value and that old value. Well, how are we going to calculate this actually? Well, we're going to have to plug into the equation that 40 years, calculate what that value is, and subtract from it the value when x is equal to 35 years. So we'll run to Desmos to do those calculations for us. And since I have a table here, I can just type into my table 35 and 40, and there's my two values, rounded to the nearest cent. Except that I have 49. Let's fix that. There we go. So I'll write those down on the sheet, and then I'll show you what's happening. So we're doing the $149,744.58 minus the $106,765.81. And that difference is the amount of what in the world? Okay. So let's do that subtraction here. We've got 149,744.58 minus 106,765.81. So that difference is $42,978.77. So this tells us that we've earned this much interest earned between years 35 and 40. Notice a ton more interest earned when compared to the first 5 years. To be clear, though, this 4,000 that we earned was a part of this 42,000. But it's still, I was way off. This is 10 times the amount of interest earned. And that's one of the big factors in the amount of value your account has is time. The longer you can invest things, the more money you get. So that's the key thing here. So describe what you learned from comparing the answers 8 and 9. Also describe how that fits in with your answer to question 7. What was our answer to question 8? The longer investment, let's not say that because we want to generalize this, because this works for things that aren't investments either. If you think about say bacteria growing on food that you left out in your kitchen, it grows exponentially. If you think about insects replicating like mosquitoes, they grow exponentially, provided there's enough resources to support the life for them. So large X values produce, let's call this faster growth. That's the point of exponential. Again, I think a picture is much better showing this. The further out we go, the further this direction we go, the steeper this graph becomes. Okay, so now we're going to illustrate this with a nice little Highlander problem. So our author really enjoys this show, apparently. It's about a race of immortals, meaning people who can't die, apparently, and they battle each other over hundreds and thousands of years. And then they're always wealthy. And people think that's fake, according to him. And he says, well, if you could time travel, it should make sense. So let's assume this person, this Highlander guy, went back to 1700 and invested $10 in an account or in a company that he knew would last to today. I believe there are a few companies out there that are this old. So we'll assume that it earns 5% each year over the lifetime of this company. So what's our equation here? Well, our initial investment is that $10, and our growth rate is that 0.05. So if you think what we did, we added the 0.05 to 1 to get the growth factor. This is the number you're multiplying by each year after 1700. And the amount you invested in there, the amount we're multiplying by 1.05 is the $10. And we're going to do this for an X amount of years. While we're sitting in here, let's just go ahead and generalize this equation. Any exponential equation you're going to write, let me take that back. Any one you're going to write in this class, we can make this a little more complicated by subtracting things from X and adding things to this piece. But for our purposes, we're just going to stick with this little basic model. This A value represents the initial value of whatever we're trying to model, and this B represents the growth factor. That's the general form of an exponential equation. Note the initial value is really the y-intercept. We're going to compare that with linear shortly. So let's continue with this problem. What is this investment worth then if we calculate the value now? So this becomes a really important problem that you're going to use in your project. We want to figure out what's the X value for the time passage here. So if we're using 2021 minus 1700, we would get 321. Now I happen to know that the lesson check for this class is this problem for this section, and I told you to use 2020, so I'll do both calculations I made this lesson check last semester or back in 2020. Okay, so we're going to do both of these values and get what our investment was worth back in 2020 and what it's worth now. Well, all we have to do is type into Desmos this thing, 10 times 1.5 to the 321, and that gets us the value in 2021. And then the answer to the lesson check would be this value. All right, so let's check these both out. Again, remember, all this guy did was dump in $10 on this company. And look at what he ends up with. $63,352,681.45. That is because you can time travel, right? That's a 321-year investment. For the answer to the lesson check, it's 60,000, so 3 million less. Isn't that wild? Almost a little under 3 million less for a 1-year difference. You're to round to 2 decimal places for the lesson check. So this is our lesson check answer. Wild. Let's just for fun toss in 1,000 years, which is what happened to Fry in Futurama. He had like 95 cents in his account, and it lasted for 1,000 years. Look at that! Whoa! Times 10 to the 22 at 5% interest. Insanely wealthy. I don't even know what that number is. I can't even say it. Billion is 13. So crazy explosion.